In the previous video, we have created our own state implementation to actuate the conveyor belt in the factory simulation. Let's see now the result using it in a new version of our factory. This time, the part does not magically appear next to the robot. We need to use the conveyor belt to bring the part to it. To achieve this, we will extend the peak behavior with the states to start and stop the conveyor belt using our new state implementation. Before using our newly created state implementation, remember that first we need to build our Catkin workspace and source it for FlexB to know about it. Once we do that, we can open the FlexB app again and use our state in a behavior. Let's load our demo behavior, pick from conveyor, and go to the state machine editor. Now, we add our state to start the conveyor belt. We type conveyor in the filter, and here it is. You can see that the tooltip shows the information we added in the documentation of the state class. We add the state, giving it the name start conveyor. Okay. Now let's reconnect our state machine so that we first start the conveyor belt. Okay. Now let's give values to the state parameter and the input key. Since this state will start the conveyor, we set the parameter stop to false. Remember the quotation marks to pass a liter of value. Okay, and for the input key, we need to pass a variable in user data. So let's go back to the behavior dashboard and define a user data called conveyor speed. Okay, we will give it as default value 100, which corresponds to a reasonable speed. Now, back to the state, and we use the user data variable as the input key. Okay, we have completed the state configuration. Let's see if we can save the behavior. Yes. Okay, now we need to stop the conveyor belt after the part is detected to pick it. So we add another state of type setConveyorPower, this time calling it stop conveyor belt. And we place it in between the detect part and compute peak. Let's reconnect the transitions again. All right. Now let's configure the stop conveyor state. This time we have to set the parameter stop to true. Now the input key. It is mandatory to provide a user data variable for the input key of a state, although it won't be used in this case, since the speed will be set to 0. We can pass the same conveyor speed variable as before. Okay, let's save our behavior again. Perfect. Looks like we are ready. Let's see if our new state machine works. Remember that to execute the behavior, we have to launch our factory simulation and also the FlexB behavior engine. This is what happens when we execute our new behavior. We open a terminal and run the launch file for the new factory version. And also FlexB. Now, if we go to Gazebo, we can observe that now the part is at the beginning of the conveyor belt. Okay, let's go to the FlexB app. Load the modified pick from conveyor behavior and execute it. Let's see what happens. Back to the simulation again. Okay, the conveyor belt is moving and bringing the part to the robot. Now it reaches the camera area and the conveyor belt stops, so it has detected it. Now the rest of the states are activated as in the previous state machine. The robot moves, the gripper activates, and the part is picked up. Mission accomplished. In this unit, we have learned to program our own simple state implementation by using the FlexV state lifecycle, and we have used it in a behavior.